Good morning, students. In the previous class, we had solved some numericals and the questions related to quantum numbers, right? I told you the quantum numbers is a very important topic. So we discussed about it. And coming to the examination point of view, this weekend exam point of view, so till yesterday's class, whatever we discussed, after Bohr's atomic model onwards, okay? Means Bohr-Sommerfeld model, the dual nature of matter, as well as Heisenberg's uncertainty principle. Then coming to quantum mechanical model and quantum numbers. Till whatever we discussed in the last class, up to that you will have for this weekend exam. Okay? I told you in the previous class also we have only one topic left. Okay? That is about the orbital diagrams. As well as one more important topic is there, mainly for competitive exam point of view. That is also nowadays they are mainly asking question based on this radial probability distribution curves in the JEE exam. Okay, normally in the statewide examinations are coming to NEET exam also. Regularly they are not asking questions based on this radial probability distribution curves. Okay. But for JEE, for high level typical questions when they want to ask from atomic structure, then they are asking questions from this radial probability distribution curves. Okay? Now let us discuss about that. Keep the heading here. Radial probability distribution curves. And then shapes of orbitals. So in today's class, we are going to discuss mainly about the radial probability distribution curves along with the shapes of the orbitals. Okay. Now first coming to the radial probability distribution curves. Curves nothing but we are going to discuss about the graphs. Okay. Now before going to discussion about these graphs, first of all we should know the terms like psi. What it represents. We already discussed about this one, and even the significance of this psi also we discussed. Here psi, or we use a capital R. Okay? The psi or capital R. Generally we know it represents wave function, or it is also known as radial probability. Okay, the psi is also known as radial probability. And we know already about wave function. Even psi square or capital R square is nothing but probability density. Okay. The psi square or R square is known as probability density. Now even one more term which gives complete idea about the location of electron in the atom, that is we call generally as a probability, is nothing but 4 pi R square. 4 pi R square psi square into dr means derivative of this R. What is small r? Because capital R we have clarity. What is smaller we will discuss further. 4 pi anyway constant, 4 pi R square psi square dr. This is known as a probability function. Okay? This whole thing is known as probability function. Instead of 4 pi r square psi square dr, they will represent this probability function as a d also. Capital D represents probability function. So in the curves or in the graphs, whatever they give in the examinations, instead of 4 pi r square psi square dr, they may give simply as a capital D. It represents a probability function or nothing but simply we can call it as probability of finding the electron. Okay? Got it? So these are the main three terms we need to know, because based on this radial probability, they are asking the graphs in three ways. Okay? So either in terms of psi or psi square or this radial probability function also, they asked questions previously IIT level also. Okay? So that is why in the starting also I told you, this topic generally is needed for NEET level exam also. Sometimes they are asking simple graph related questions. But coming to JEE main and advanced, sometimes they are asking some typical graphs related to this. Okay? Now, what are these three? What are meant by these three terms? Then we will discuss about the graphs. Along with that, let's note down what is meant by this small r. Okay? This is r represents the distance from, for example, here we are going to measure the probability of finding the electron. We know electron will be continuously revolves around the nucleus. If the electron is in the first orbit, it will be closer to the nucleus. If it is in the second orbit, somewhat away from nucleus. Okay? So here, this small r represents the distance from which at a particular point, the distance between that point and the nucleus. Okay? So for example, if this is the size of the atom, and this is the nucleus. Okay? Now R is nothing but a point, any point in an atom. It represents from that point to the nucleus, the distance between any point in the atom from the nucleus. Okay? So nothing but it represents the distance between a particular point and the nucleus. Okay? Small r represents the distance from any point to the nucleus. Okay? So R represents distance from any point, any particular point to the nucleus. Okay? So these are the terms we need to know regarding the probability distribution graphs. Because we are getting three types of graphs. All the three cases, we are drawing the graph or any of the one versus R. Okay? So let us discuss the first type of graphs. Now, let's discuss about the first type of graphs. These are the graphs drawn between psi. Psi nothing but what? Radial probability versus R. Okay? These are the graphs between wave function or radial probability versus R. Okay? Now when we draw the graph for a particular orbital, first of all, I am going 1s orbital I am going to draw. So this is the graph I am going to draw for 1s orbital. So when we draw the graph for 1s orbital, we are getting the graph in this way. Okay? So what it represents? When R value is small, R value small means what? The distance from the nucleus to that point is small. Nothing but the electron is very close to the nucleus. When the electron is very close to the nucleus, we know the probability of finding the electron will be more. But when you are moving away from the nucleus, the probability of the finding the electron will be decreases. So in the same way for 1s orbital we draw. But when we draw the graph for 2s orbital, so this is the graph for 2s orbital between R versus psi. Then we are getting the graph in the way like this. So slowly decreasing. Then we are getting the graph like this. Okay? So if we observe this point here, it representing the negative values for psi because it is the origin. Origin means its value is 0. When you come down this line, this represents the negative values of psi. So that is why we are not following the graphs related to psi versus R. Okay? But still, why I am giving this graph is, by giving this graph, they are asking one type of questions. Okay? The question what they asked previously based on this type of question is, in the given graph, how many number of nodal planes are there? Okay? So before discussion about these graphs, we should know about the nodal plane. Okay? Nodal plane nothing but, or nodal region nothing but, the region around the nucleus where the probability of finding the electron is 0. Okay? So similar way, we discussed one definition. What is that? Orbital definition. What we said orbital means the region around the nucleus where the probability of finding the electron is maximum. Okay, not 100%, but percentage I given to you, it is around 90 to 95%. Okay, so there we can find some region. So observe this point. If you observe this point, what about the value of probability of finding the electron is 0. Nothing but at this point you cannot find the electron. So this region where the probability of finding the electron is 0. So such type of region is known as a node or a nodal region. Okay? I will give the definition later. After completion of these graphs, I will explain to you how to find the nodes as well as the nodal regions. Okay? Now one more example let us see. For a 2p orbital, if we draw the graph between psi versus r, we are getting the graph in this manner. Okay? So enough for all orbitals, no need to draw, no need to remind. Just look at these three graphs. Okay? Now, to avoid these negative values of psi, now the second time, now we are going to draw the graph between. Suppose to copy these three, then we will discuss about second type of graphs. Okay? Now coming to the second type. Now this time we are going to draw the graph between psi square versus r. Now coming to the first graph. psi square versus r we are going to draw. Okay, these are second type of graphs between psi square versus r. So in the same way as like the previous graph, here also for 1s orbital we will get in the same manner. But coming to this 2s orbital, we are getting the graph like this. Okay? Because as I already told you, when the graph is touching this r, x-axis, nothing but what? The corresponding y coordinate is 0. I think in mathematics coordinate geometry, all of you know this. Right? When this line touching this x-axis means y coordinate is 0. Okay? So here, there is no probability of finding the electron. That region where the probability of finding the electron is 0 is known as no. Okay? So if they ask how many nodal regions are there for the 2s orbital, if they ask, how much you will answer? One time it is touching this line. So that is why the number of nodal planes is 1. Okay? Now coming to the graph for psi square versus r will be same as like psi. Okay? Is it touching the graph? No, it is not touching. So 2p don't have any nodal regions. Right? So these are the second type of graphs drawn between psi square versus r. Okay? Now coming to the last type. Coming to competitive exams, we will get questions mainly based on this third type of graphs. So if you observe the NCERT, also we have mainly these type of graphs only. So focus more on these graphs. Now, so why somebody may get doubts, sir, why to focus more? Because many times they ask questions based on these third type of graphs. Okay? And even the probability of finding the electron will be given more closely by this probability function. So 4 pi r square psi square dr versus small. So these are the third type of graphs. Now let us draw this graph for 1s orbital. This is the graph between 4 pi r square dr psi square. Okay? So I have taken this one on y-axis as like the previous one, and the distance between the particular point to the nucleus is taken r. So this is origin. Yet this point means r value is very small. So means the distance from nucleus to the electron is very less. Okay? When electron is away from the nucleus, r value will be higher. Right? Now when we draw the graph for 1s orbital, look at this carefully. So we are getting the graphs in this way. Okay? So for 1s orbital, we got the graph in this way. So we got one peak. Okay? So what this peak represents? This peak represents the maximum probability of finding the electron. Because I told you, this probability function is nothing but the probability of finding the electron. So this peak of this curve represents where the probability of finding the electron is maximum. The corresponding r value for 1s orbital, if we measure, they got the value at this point is, the value they got 0.53 angstroms. Okay? I think by looking at the value, we can remember or we can remind the radius formula given by Niels Bohr. So what formula given? Radius of nth orbit is equals to 0.53 into n square by z angstroms. Okay? For a hydrogen atom, z value 1. For the first orbit, n value also 1. So what is the final radius of a first orbit given by Niels Bohr? 0.529 angstroms. Okay? So when we draw the graph between the probability function and r, the corresponding value for 1s orbital is nearly same as that of radius of the first orbit given by Niels Bohr. Okay? So remember that point. Note down in the notes also. Right? What you have to note down? When we draw the graph between probability function versus r, then the radius of this orbit given by Niels Bohr is same as that of the value obtained by the graph. Okay? Now, coming to the graph drawn between versus r. Now this is going to this is for 2s orbital. For 1s orbital, we got the graph like this. Coming to the 2s orbital, they got the graph in this manner. Okay? Again for 2s orbital, it is touching this x-axis. So nothing but corresponding probability of the electron is 0. So nothing but this represents node. Okay? Or nodal region. So for 2s orbital we found one nodal region. Right? So somebody will doubt. Sir, why we got two curves? So this is for 2s orbital. So if you draw the graph, so like this we are getting. So this represents node. Now, some of you may get doubt. Sir, for 1s orbital, we got only one peak. But coming to 2s orbital, we got two peaks. Anyway, the maximum peak is this one. Means where the probability of finding the electron is maximum is this one. Okay? The corresponding distance from the nucleus is this. Okay? So coming to our doubt, what is about this first one? Okay? If you observe that this first peak is close to the nucleus, right? Because these R values represents when the electron is close to the nucleus. This value represents when the electron is away from the nucleus. You tell me, 1s orbital is close to the nucleus and 2s orbital is close to the nucleus. We know 1s orbital belongs to first orbit, 2s orbital belongs to second orbit. Okay? So the electron present in a 2s orbital will have less probability of finding the electron in the nearby the nucleus, and it will have more probability of finding when it is moving away from the, somewhat away from the first. Got it? Means the electron present in the 2s orbital will have less probability in the first orbit, and it will have a more probability in the second orbit. Remember? Okay? Because last 2 years back only they asked one question in the advanced level based on these graphs. I will give that question also. So always for any orbital while you are drawing the graph, for a large orbital when you go, large nothing but away from the nucleus. If you take the distance from the nucleus, if you see, when the orbital, for example 3s if you take, it will have even small peak when it is close to the nucleus. Okay? If you take 4s, it will have even a small peak closer to the nucleus. Okay? Now let us come for 2p orbital. Now coming to the 2p orbital, we got the curve in this manner. Okay? So means it is not touching the x-axis. So means the 2p orbital don't have any nodal region. Okay? I'll explain one question. From that you will come to know how many nodal planes are there, how to find how many number of nodal regions. I'll give a small formulas also to find. Even I will explain to you how to find from the graph. I think you got some clarity. When it touches the axis, x-axis or the r, then it represents the nodal region. Okay? How many times it touches? That represents that many nodal regions. The first copy these three graphs. Then we will discuss clearly about nodal regions. So first keep the heading as node or nodal region. Okay? Node or nothing but nodal region. So let us note down the definition for this nodal plane or nodal region. We already discussed the definition. The region or the space around the nucleus, the region or space around the nucleus where the probability of finding the electron is 0. Okay? The region around the nucleus where the probability of finding the electron is 0 is known as nodal region, or also simply called as a node. Okay? Then let us discuss about the different types of nodes. There are mainly two types of nodes are there. One is radial node and the other one is angular node. Now first coming to the radial node. Okay. Now coming to this radial node. To calculate this radial nodes, note down the formula. The number of radial nodes is equals to n minus L minus 1. Okay. The number of radial nodes is equals to n minus L minus 1. L means azimuthal quantum number. Now coming to the other type, second type, that is angular nodes. Angular nodes. To calculate the number of angular nodes, is equals to L, azimuthal quantum number. Okay. So if they ask you to find the number of angular nodes for S subshell, for S subshell how many? LL is 0. So the number of angular nodes for a S subshell is 0. Okay. Due to its spherical shape, it don't have any angular nodes. Okay. Because in all the planes it will be present. So that is, we don't have any angular nodes. Okay. Now, if they ask you to calculate the total number of nodes in a orbital, the total number of nodes is equal to what? Sum of these two, angular nodes and the angular nodes and the radial nodes. If you add these two, so minus L plus L gets cancelled. So the formula to find the total number of nodes is equals to N minus 1. Okay. So remember three things. If they ask particularly to find radial nodes, the formula is L minus 1. N is principal quantum number, L is azimuthal quantum number. If they ask particularly angular nodes, simply azimuthal quantum number. Okay. Generally, instead of these two, in the examination, they are asking to find simply the number of nodes or nodal regions in a given orbital. So here the formula is N minus 1. Okay. Now let us solve some questions. Then you will get idea about this. Here this topic is not very easy to understand. I know it is slightly confusing by looking at all these type of graphs. In the starting only I told you, because of such things only they are asking mainly in the JEE. Okay? So don't worry. After solving 2-3 questions, definitely you will be confident to solve the other questions. Right? Now coming to the first question. Calculate the number of radial nodes in 3p and 4d orbitals. Okay? Calculate the number of radial nodes in 3p and 4d orbitals. Now first let us take the 3p orbital. So by looking at the 3p orbital, we came to know the L value is 3. What about the L value for p orbital? We know for s orbital 0, for p orbital L value is 1. What is the formula for radial nodes? Radial nodes, formula what we learn? N minus L minus 1. Okay? So for 3p orbital, 3 minus 1 minus 1, so we will get only 1 nodal plane. Okay? So now, what will be the graph for this 3p orbital? Because sometimes they will ask you to find out of the given graphs which represents 3p orbital. So look at it. We came to know that for 3p orbital, so where d nothing but 4 pi r square dr psi square. So if you draw the graph for this one, for 3p orbital, how many graphs we are getting? Sorry, how many nodal planes we are getting here? So we came to know we are getting one radial node, right? Got the logic or not? How many number of angular nodes will get? One. Okay. Now what will be the total number of nodes for a 3p orbital? So total nodes is equals to n minus 1. So 3 minus 1, nothing but 2. Okay? So the number of nodes we get for this one is 2. Right? Got my point or not? So if they ask only to draw so when they are drawing graph between these two, so we are going to get the graph related to the number of nodes. Okay? For a 2p orbital graph we already drawn. So for that we did not get any nodal regions, because for a 2p if you take 2 minus 1 minus 1, so the number of nodes will be 0. Okay? Here the number of nodes is 1. So we will get graph like this for 3p orbital. Okay? Got the point or not? So these graphs represent radial nodes. Okay? Not the total nodes. Right? Remember that point. So when we draw the graph between probability density versus the probability function versus R, this graph represents the number of radial nodes. How to find the number of radial nodes? N minus L minus 1. Okay? Now coming to the other orbital given to us, that is 4d orbital. What about n value? N value 4. L value for d orbital is 2. Okay? Now in this case, radial nodes is equals to 4 minus 2 minus 1. So it will also have only one number of radial nodes. Okay? Note. Now you got idea how to calculate number of radial nodes. The formula is n minus L minus 1. Okay? Now coming to another question. What are the question? Which of the following graphs represent five D orbital? Okay? Which of the following graphs represent 5D orbital? Now given options are, so all these graphs are drawn between probability function versus R. Okay, so all the four options are drawn in the same manner. Now coming to the first graph. That is first option. Now coming to second option. Now coming to third option. Option C is this is option C. Now coming to option D. Okay, so these are the four options given to us, and they are asking to find out of the four which graph represents 5D orbital. Okay, I gave you only three graphs. I think you only copied only three. 1s, 2s, 2p I given in the notes. But in the examination, they ask a 5D orbital. Okay, I told you in the starting also. For all the orbitals we cannot draw in the notes and we cannot by heart also, right? Okay, we should be in the position to answer for any type of question. Okay, this for any type of orbital if they ask how to answer, we should be ready. Okay, how can we say we can answer this type of question? First of all, these graphs represent probability of finding the electron, as well as this point is what we discussed, and the graph touches this x-axis. What I told you, that represents nodes, right? These graph represents the number of radial nodes. For a 5D orbital, calculate number of radial nodes. How much it is? 5 minus L value for a D orbital is 2. 5 minus 2 minus 1. So nothing but we should get 2 radial nodes. Okay? 2 radial nodes we will get for that particular 5D orbital. So is the first option is correct? No, because in the first option we have only one node. So this option is wrong. Is there any option? Is there any nodes in this given second option? No. In the given here, this represents there is a no node. So this is also not the correct answer. What about this graph? In this graph, the line is touching the x-axis 2 times. So in this case, the number of nodes is 2. Let us check. Can we say option C is correct answer? No. Let us check option D also. In the case of this fourth option also, we are getting the number of nodes as 2. Okay. Then out of option C and option D, which is the correct graph? I think many of you got idea. Or once look at the graph carefully, then tell me your answer. What will be your answer? Option C or option D? Okay. So first let us observe the graph keenly. Then we will come to know what is the difference between these two. The difference is, in the case of option C, the maximum probability of finding the electron is very less when it is close to the nucleus. When you are moving away from the nucleus, because it is in which orbit? Fifth orbit. When the electron is present in fifth orbit, its probability in first orbit is less. Correct or not? But what they given in the option D, they given more probability of finding the electron in the first orbit, and it it reduced in second orbit, then increased in the next orbit. Is it is correct? No. Okay? So remember that point. So in the case of this one, when you are moving away from the nucleus, for understanding purpose I said first orbit, second orbit. Don't think like that. Okay? So it is the distance from the nucleus. When you are moving away from the nucleus, for an electron present in a 5d orbital, the maximum probability will be increases. It is simple thing to understand. When you are in fifth orbit, your density first orbit is less. So close to the nucleus, the probability of finding the electron is less. But in the fourth option, they give it maximum. So that's why this graph is also wrong. So the graph which is representing 5d orbital is the graph. Understood? It is not a difficult thing. First, out of the four options, what we have to focus? We need to calculate number of radial nodes for the given orbital. Then we should check from the four graphs. Okay? So copy this first. So this is the information about nodes as well as nodal region. In the next class, we will discuss about the orbital diagrams as well as some other topics like stability in the half field as well as a magnetic moment. Okay? So in today's class, what will we discuss? Focus more, because I told you, when they want to ask a tough question or a typical question from atomic structure, or when you go from JEE exam point of view also, they are asking questions based on these graphs. These are not the tough ones. Only the formulas what we got in today's class, calculation of number of radial nodes, n minus L minus 1. Mostly they will ask this one only. Or total number of nodes, n minus 1. Number of angular nodes, it is L. Okay? There will be no angular nodes for S orbital. Whatever the types of graphs I given to you, let's go through all these. But today your focus more should be on for weekend exam preparation. Right? Focus more on quantum numbers as well as de Broglie's dual nature of matter and Heisenberg's uncertainty principle. Okay? So all the questions from our material, prepare well for the weekend exam, get good marks.